Welcome to Geometry PLP, Essential Standard 2, Learning Target 6A, Introduction to Geometric Proofs. You've been talking about algebraic proofs. Now we're going to start talking about geometric proofs. So geometry instead of algebra. But first we're going to do a little story. Take a minute, go ahead and pause your video, read through this little story, and see if you can change the order of the statements in order for it to make a bit more sense. So pause your video and do that, and then we'll be right back. Okay, hopefully you've reordered this story. How I would go about it, when I read this, it doesn't make a whole lot of sense, but something I notice is everything seems to happen in the evening or overnight. So I'm going to start with coming home from work, and then, oh yeah, I forgot to say something before I went to the gym. Running laps probably happened at the gym. Then I went home and walked my dog. And after dark, watched Hulu and then went to sleep. So let me read this in the order that I arranged it and see if you think it makes more sense. After work, I went to the gym. Oh yeah, before the gym, I drank my pre-workout shake. I ran 10 laps around the track and swam 15 laps in the pool. I then went home and walked my dog in the neighborhood before the sun went down. After dark, I watched Hulu and passed out in bed. I didn't sleep very well and woke up 4 times through the night. You see that order is very important for something to make sense. Otherwise, you're not sure if you slept the night before, or when this happened, or did you walk the dog before the gym? It gets a little confusing. But if we put everything in the right order, it makes a whole lot of sense. That's really important when we're trying to work with proofs. You have to do things in the right order. In life, you're asked to prove things. What does that mean, to prove something? So basically, you have to tell somebody something, and they have to believe it beyond a shadow of a doubt. Then you've proved it. If you just say something to someone, they may or may not believe you. But if you have facts to back it up, then they're going to believe what you said. So when we prove something in geometry, it has its own language. So just like the story we talked about, order and structure are important to make sure you know what's happening in the proof. A definition of a definition. A definition is a statement of the meaning of a word. Definitions are used to help prove statements in geometry. All definitions can be written as biconditional statements. Hopefully you remember that from a few lessons ago, what a biconditional statement is. An example is supplementary angles have a sum of 90 degrees. That's a definition. I can write that as a biconditional statement. Angles are supplementary if and only if they have a sum of 80 degrees. That means if they're supplementary, they add to 180. If they add to 180, then they are supplementary. It goes both ways. That's what a biconditional statement says. Let's go through a few examples. An angle bisector is a line that divides an angle into 2 congruent angles. A conditional statement would be, if it's an angle bisector, then it divides an angle into 2 congruent angles. Now, do you remember what a converse is? We switch the hypothesis and the conclusion. So I can say, if it divides an angle into 2 congruent angles, then it is an angle bisector. Now remember, the biconditional puts those two together. So it is an angle bisector. if and only if it divides an angle into two congruent angles. We can do this with any definition. Here's another one. Vertical angles are the pair of opposite angles formed when two lines intersect. The conditional for that would be, if it is a vertical angles, then they are a pair of opposite angles formed when two lines intersect. The converse would be, if they are a pair of opposite angles formed when two lines intersect, then they are vertical angles. The biconditional of that would be, they are vertical angles if and only if they are a pair of angles formed when two lines intersect. Remember, that goes both ways. That's both the conditional and the converse. We can use these definitions to pull out information from diagrams. Use your previously known definitions to make conclusions from the following givens. So we're given that KM, so this line right here, bisects JKL. So what is the definition of an angle bisector? An angle bisector divides an angle into two congruent angles. So can I say that angle JKM is congruent to angle MKL? I can, because the definition of an angle bisector tells me that these two angles are going to be the same measure. For number 2, line segment AC is perpendicular to line segment ED. So these two lines are perpendicular. What is the definition of perpendicular? Two lines are perpendicular if they meet at right angles. So I can say that all of the angles in this picture are right angles. This is a right angle. ECBC is a right angle. CBD is a right angle. And ABD is a right angle. Because perpendicular lines meet at a right angle, I know that all these angles are right angles. A couple more. I know that M is the midpoint of FG. So this is my midpoint. What does that tell me about FM and MG, these two smaller line segments? I know that I can say FM, line segment FM, is congruent to line segment MG. And that's because of the definition of midpoint. The definition of midpoint tells me that it's a point that divides a segment into two congruent segments. Okay, one more thing. AMO, so AMO is vertical to PMB. So I know that these two angles are across from each other. From the definition, it tells us that these two intersect each other, that these two lines intersect each other. That's probably not going to help me a whole lot. But the end of the definition tells me that vertical angles are congruent. So I know that angle AMO is congruent to angle PMB because vertical angles are congruent. Now, what if I'm not given any more information? All I have is this picture. It's a right angle. How could I prove to you that this is a right angle? Well, I could draw in a little square, but that would kind of be cheating because I don't know that it's a right angle. I just forced it to be a right angle. It doesn't tell me it's a right angle. So I'm going to go ahead and measure it. I'm going to measure it with a protractor. So I'm going to take my protractor, put it right here on the vertex of my angle. When I do that, I can see that this angle is exactly 90 degrees. What is a right angle? A right angle is an angle whose measure is 90 degrees. So is this a right angle? Yes, we're certain this is a right angle. I want to prove that M is the midpoint of AB. Well, again, I don't have any information given to me, so I think I'm going to have to measure. So I'm going to take a ruler. If I take that ruler and put it over here, I'm going to see that the distance from A to M is 6 centimeters. If I move it over here, the distance from M to B is also 6 centimeters. Does that tell me that M is the midpoint? It tells me it's halfway between the two endpoints, which is the definition of a midpoint. So M is the midpoint of AB. Now we'll get ready to get into some actual geometric proofs. See you next time.